All right, this is Algebra 1, the practice quiz. This is going to be the key. For this first problem, whenever you multiply the same base, you really add these two exponents. So 8 plus 2 here is going to be 10. And the reverse of that rule, whenever you divide and you have the same base, this is both x and x, we're going to subtract. 16 minus 4 is 12. That's 16 minus 4. That's 8 plus 2. Number 2, and again, don't worry about points for now. Number 2, there are two things that you want to do. First, these are not the same. These are not the same. Not the same. Which means all you can do is distribute the 5 into here, into both of these terms, and you get 3 to the power of 6 times 5 is negative 30. Again, negative times a positive is a negative. And then for the denominator, we have 7 to the power of negative 3 times 5, negative 15. I'm looking through here. It doesn't look good. Okay, well, I'm noticing this one is positive. So what happens if I use that rule where it's one of these rules, here, let's do it off to the side. If I have x over 1 to the power of negative 1, this is equal to 1 over x to the power of positive 1. You're allowed to flip these as long as you get rid of that negative. So I'm going to flip this one. It's going to be 3 to the power of positive 30. And then in the numerator, we're going to have 7 to the power of positive 15. And oh yeah, that's that one right there. Perfect. So that is the one answer. And again, only one answer. Moving on to number 3. Again, for all of these, don't worry about the grade. There's supposed to be a mistake. And if there's no mistake, then you select A. So this first step is really hard to see. Let's see what happened. Really what they did, what Natalie did, was they wrote this as 4 times 2, and then they factored out the power of negative 3, and then put this as the power of 0. They kind of didn't show that work. And then from there, 4 times 2 is just 8, and that's exactly what they got right here. That's 8 to the power of negative 3, 0, 0. Everything matches up there. So far so good. Most people think that step 1 is a mistake, but it's actually just skipping 2 steps. And then again, negative 3 times 0 is 0, and then anything in the power of 0 is no. It's supposed to be 1. So there's a mistake here in step 3. Step 3, there's the mistake. The correct answer is D. Number 4, which of the expressions are equivalent to that? And I'm looking through here. Okay, well, we can kind of use that same trick where you kind of factor out one of those powers. So I can say this is 2 over 6. Factor out that power of 5. Bring this 5 and 5 to the outside, and then keep the parentheses in here. And then this can simplify. 2 divided by 6 is 1 divided by 3 to the power of 5. And 1/3 to the power of 5. Darn, it's still not in here. Okay, well, what we can do is we can flip this thing. We're going to flip the top and the bottom, and this is going to be 3 over 1. But that means that this 5 up here is negative 5. And this is the same thing as just 3 to the negative 5. And oh yeah, that's this one right here. But the problem is there's 2 answers. So there's another answer somewhere out here. So where is it? It doesn't look like it's A, because that's kind of what we had up here, but it's to the power of 5, so I don't think it's A. Maybe this one can be simplified more. Let's play with D. So if I do this one, and I bring this negative power and I bring it down, then I have 2 to the power of 5 in the top, and I have 6 to the power of positive 5 in the denominator. And that's exactly what we had to start with. That's the same answer. So that is also a choice that you should be making. All right, moving on to number 5. These are just, you have to have these memorized. Memorize these. I can spell. So the cube root of 512 is 8. Oh gosh, I'm not 100% sure about that. The square root of 256, that sounds like a 16 to me. The square root of 169 is 13. The cube root of 216, it ends in 6, so there's only one option, and it's a 6. Moving on to, skip down there to number 7. Square root. This one is just the square root of the top, 144, and the square root of the bottom, So the square root of the top is 12, the square root of the bottom is 5, and it's just 12 over 5. This one is very similar because to the ones we've done before, as long as you know what the square root of 324 is. So the square root of 324, I think, is 18, which means the square root of 3.24 is 1.8. And you can check this. 1.8 times 1.8. 8 times 8 is 64, so there's a 4 that comes down here. 8 times 1 is 8, plus 6 is 14. 1, keep the 0, 1 times 8 is 8. 1 times 1 is 1. Adding these together, and we get a 4 there, 12. So carry the 1, 1, 1, 1, that's 3. And then there's 1, 2, 1, 2. 2 decimal places, so 3.24. Number 8. So this one is another square root, but it's not nice, and you can't use a calculator, so no calculator. You're looking for perfect squares. So the way that I do these is, again, I haven't been in class to teach these, but I do a factor tree. So what times 108? And in the factor tree, you have to use perfect squares. So for this number right here, it needs to be like 4, 9, 16, 25, 36. It has to be like one of those. And I don't see, okay, I think 4. I can use 4 here. If I do 4, it has to be a 20, well, 25 would be 100, so 26, 27. 7 times 4 is 28, so that's how you get that last 8 number. Alright, and 27, can I factor that any further? Because once you get the square root of 4, that should be a square root, because the square root of 4 times the square root of 27 equals 108. The square root of what times the square root of what equals 27? We can say, okay, there's another 9 here. This can come down here, and you can say the square root of 9 times the square root of 3. So now what do we have? We have, this is equal to, we'll say the square root of 108 is equal to the square root of 4 times the square root of 9 times the square root of 3. The square root of 4 is just 2. Square root of 9 is 3. Square root of 3 can't do anything, it's still square root of 3. So our final answer is 6 square root of 3. Moving on to number 9, it's just another layer of difficulty. We're first looking at the square root of 20, and then over here do the square root of x to the power of 9. The square root of 20, again, make sure your factor tree has a perfect square, and one of the perfect squares is 4. 4 times 5 is 20, and I can't go any further. And this is equal to, again, you can kind of do your factor tree as x to the power of 8 times x to the power of 1. And the shortcut here is you just take half. This is really x to the power of 8 to the power of 1/2 times that square root of x still. And this is x to the power of 8 times 1/2, which again turns into x to the power of 1/2 of 8 is 4. And over here we still have that square root of x. Over here, square root of 4 turns into a 2. Square root of 5 you can't do anything with, so we're going to leave it as square root of 5. And we have all of our pieces. So we have 2x to the power of 4. That's this and this. And then we have our x and 5. We have the square root of 5x. And there is our final answer. I guess I should draw lines for where everything went. This went right there. This went right there. This went right there, and this went right there. Alright, our last problem on our practice quiz. Here we go. Oh man, we have things inside and outside. What is Mr. Snell doing to you guys? For this one, I'm going to multiply them together first to make my life easier. I have, this is going to be, do I want to multiply it together? Because 15 times 60 is kind of hard. Maybe I want to just do a general factor tree. There's another way of doing a factor tree. So I have a 12 out here, and then I have the square root of, that was not a very straight line, the square root of 15 times 60 times y to the power of 5 times y to the power of 4. And now I'm going to do a factor tree kind of like this from both of these. Well, I know that I can pull a 3 out. So let's just do one. I'll do 2 separate factor trees. This was the square root of 3 times the square root of 5. Can't go any farther. What about the square root of 60? That can be the square root of 3. Again, I chose 3 because there's another copy of this. And then what do we have left over? Square root of 20. Do I have some way to get another 5? If you can get 2 of these, then they work together really nicely, because the square root of 20 is, oh yeah, you can get 5 and 4, right? Square root of 5 times the square root of 4. And then these two together make the square root of 25. These two together make the square root of, wait, those don't make anything, sorry. These two together make the square root of 9, and then I still have the square root of 4, which actually works out really nicely. Check that out. Because this turns into 3, this turns into 5, this turns into 2, and we don't have any more square roots, which is really nice. What about over here with the y's, the variables? Well, this turns into y to the power of 5 plus 4, still under the square root, which is the square root of y to the power of 9. That's going to be the square, again, I'm kind of doing a factor tree here, so factor tree. This is the square root of y to the power of 8 times the square root of y to the power of 1. And our shortcut is take half of 8, so this is y to the power of 4, and this turns into the square root of y. And then you have this term, this term, this term, this term, and this term to multiply. 3 times 5 is 15, times 2 is 30. So our final answer, if I scroll down here, is going to be 30. That went right there. We have a y to the power of 4 to get, so this can be y to the power of 4. And then we also have this square root of y, and there is our final answer. A lot of work there. Thanks for watching. If you guys have questions, please let me know. You can comment on Google Classroom. And with that, I will see you guys later.